Welcome back, guys. We're on graph number 1. So we've got the following. We've got 5x squared plus 6x to the third. Okay, so based on the information from the last one, here the lead coefficient is 6. It's positive. A is positive. The reason that's the lead coefficient is because that's the highest degree is x to the third, even though x squared is written first. So what I'm going to do is I'm going to kind of make like a little chart that shows me everything I need to know. So this is x to the third, so it's not a parabola. It is a shape like this. Okay. This is facing the correct way. It's that or this, and I know that it's this one and not this one because this is positive. Okay. Let's look at some... say this is equal to y. Let's look at some zeros of this thing. We have 5x squared plus 6x to the third is equal to y. 0. We're looking for 0. So if we factor out an x squared, we have 5 plus 6x equals 0. So now x squared is equal to 0, which means x equals plus or minus 0. Okay, now this is very important because this is x squared. When it gets to 0, x equals 0, I know that you can't have plus or minus 0. That's obvious. So when it gets to 0, instead of going through that point, it's going to bounce back down and stay below or above the line depending on what side we're on. Okay, let's figure out the other one. We have 5 plus 6x is equal to 0. So now we have 6x is equal to negative 5. I've subtracted 5. Divide by 6. X equals negative 5, 6. Okay, so let's go ahead and use what we know. I'll try to graph this. Negative 5 sixths. So if I go over here is negative 1, here's negative 5 sixths. We're just estimating. Okay. We have 0. That would be right here. Okay, now we know that it's going to look something like this. Okay. It might not dip down as much, but it will dip down at some point. So let's go ahead and try to graph this. We know that it on the left side, it is decreasing at this side because we talked about that in the last video. We said that this is positive, and that means that on the left it's decreasing, on the right it's increasing. So we know this happens. Okay. Now a moment ago I spoke to you about 0 being x squared, and when it's an even power, it will not go through this and down into the negatives. So what that means is it's going to stay up there, something like that. So notice how this one actually went through and went down into the negatives, but this one stayed above in the positives. Okay, that is the result of the degree of this being x squared. So if you ever get x to the third equals 0, this one will cross through. This one will do exactly like that one does because this is a odd power. Okay, I forget what they call this. They call this the degree. I can't remember the term right now, but it looks something like this. So let's go and look. I might have made the bump too high. Let's look at this. We're going to go here. I'm going to enter this for you. So we've got y is equal to 5x squared plus 6x to the third. So as you can see, very close to what I've drawn. It comes up, it goes back down. If you want it to be the most precise, you obviously have to plug points in at half, negative 1/2, and things like that. However, it's very hard to get exactly precise, so I'm just kind of making sure you know the basics and you can kind of decipher what a good polynomial should look like. So there's that one. We've got that kind of graph. Now, a couple of other things, or one other thing I wanted to bring up. Remember, there's always one curve less than there is the degree of it. So this is degree 3 polynomial. There's one curve, two curves. So there's two curves to this one. So let's look at another one and try to solve that one. So we've got that one taken care of. Let's do 7x squared plus 9x to the 4th. Okay. Oops. Where did it go? I've lost it. Where did my thing go? Ah, here. Okay. So we've got this. So here we go. This is x to the 4th. That's the degree. A is positive. So we know it's kind of like this shape. So notice there's 1, 2, 3 curves on this. So one less than the degree. We know it's increasing left and right. Okay, that's obviously what this picture shows. So if you know the picture, then you kind of know that. Let's find some zeros. We have 0 is equal to 7x squared plus 9x to the 4th. Okay, so then we have okay, 7 plus 9x squared. Okay, so we have zeros at, okay, I want you to guess, does this go through the graph into the negatives from the positives, or positives to negatives, or negatives to positives, or does this stay on the same side that it is on? Okay, obviously this one is going to stay on the same side like the last one did because this is x squared, it's an even power. Multiplicity is what that is called. The multiplicity is 2. If it's an even multiplicity, meaning an even power, then it is it stays on the same side. And then we have 7 plus 9x squared is equal to 0. We subtract 7. We divide by 9. X equals plus or minus I square root 7 over 9. So obviously this does not have any more zeros. This is the only real zero, so that's the only one we can graph, the x equals 0. Because remember, this one is imaginary. So let's go ahead and try to draw this the best we can. We know it has some kind of 0 here. And there are no other ones because this is imaginary, so it's going to have to be increasing on both sides. So I think it might go something like, we've got it coming from here. Let's count, that's too many curves. So I think it goes something like, how do I get this? Something like that, maybe? I think that's still too many curves. 1, 2, 3, 4, 5. It is. I'm just having a hard time drawing it, but let's look at it. It's going to have that many curves. So let me hook my keyboard back to my Surface Pro. We have y is equal to 7x squared plus 9x to the 4th. Oh, okay. So you're going to wonder, why does it look like a parabola? Sorry, that's why it's not coming out as nice as I thought it was going to. It looks like a parabola because it's not, x squareds can look like parabolas because the little curvature thing that's going on, it's just so minute that you can't really tell the difference. That's why I'm having such a difficult time trying to draw that W from before. Okay, that's why I'm having a hard time trying to draw this, because it doesn't dip here and here, it dips in the middle. And what that does is it effectively brings this down and makes this look more parabolic than it does anything else. So if I gave you this on a test, I would make sure that it looked more like a W or something like that than anything. But just know that for the x squareds and things like that, they can still look like parabolas, even though they're technically not, because it probably looks more like this down there. It goes up and down right here, and then it goes up. But since the points since that little bump thing is so small, it doesn't actually like affect the graph from Desmos, because I think you'd have to, I wonder if I keep zooming if it gets better. No, it doesn't look like it. I don't know how far I would have to zoom, but I guess we can't really see it that well. I guess right here it looks like it's a little bit above, but then like over here on the side that it would be symmetric, it doesn't look like it does that right here. If it was a parabola, right? Because parabolas are symmetric, so negative 0.06 should match 0.06, which I don't think it does exactly, but maybe. So that is how you graph polynomials. The main thing, know that it's increasing on both sides. I think you guys will do okay with this. I will make sure that it's a nicer graph for you so that you can see the W or whatever. So not this graph, more like this. There are other graphs on here, but let's do one more. First things first, is number 9 a polynomial? And the answer here is no. How do I know? Because if you do x squared divided by x to the third, that's x to the negative 1, and that means that the power is negative, and therefore it can't be a polynomial, because polynomials all have positive powers that are integers. Let's graph number 10. So we have x squared over 3 plus 7 over 3. So this is a parabola, even though it didn't look like one in the beginning probably. So we know it's going to be like this because it's 1/3 out here. Okay, positive. Upward facing, positive. So then we've got that. This is going to be wider because if a is positive and it's between 0 and 1, it's going to make it more like this than like this. Let's find the vertex. X equals negative b over 2a. Well, there is no b, so this is 0 over 2 times 1/3. So this is just 0. So if I plug 0 in, then I get 0 7/3. Okay, so I think we're ready to graph that part. So we've got 0. Here's 1 7/3 is right here. Now, do I need to find zeros of this? Well, if I know that it's upward facing and it has a intercept at 0 7/3, it's going to be facing this way. And therefore, I do not need to find zeros because I know that this does not cross the x-axis. Here's the x, here's the y. And therefore, zeros only occur on the x-axis, so it cannot be the case that it's that. So if we go to Desmos, let's do that. Okay, so if you see it, you got your parabola. Notice it's a little bit wider. Then if I put, I'll just show you how it's wider, because you might not believe that. Plus 7/3. So there's the x squared plus 7/3 without the dividing by 3 to the x squared, and that is with the x squared, or with the 1/3. So the blue one is the wider one. And there you have it. You can kind of see what I'm talking about. Do you see that it's increasing on the left and the right because it's a parabola? There's no zeros because it's upward facing and its vertex is higher than the x-axis. If it was lower than the x-axis, then it would have, if it was lower, so let's say it's negative 7/3, then you can now see that it does have x-intercepts because it's lower and it's facing upward. If it's higher and it's facing downwards, then it would have x-intercepts and things like that. So just a lot of information. The more you do this, the better you'll get at it, and the better you get at it, the easier this will become. So I hope this helps, guys. Keep watching the videos, keep doing your Alex homework, ask me questions, come to meetings, and we will take care of you. I hope you're doing well. Thank you, guys.